June 1944, Rechlin Test Facility, Central Germany. The morning sun filtered through bomb-damaged skylights as Oberleutnant Karl Bauer, chief technical analyst for the Luftwaffe's captured aircraft program, walked toward Hangar 12. His boots echoed on the concrete floor. Behind him, 3 junior engineers carried measuring equipment, notebooks, slide rules. They were here to examine something that should not exist. On the tarmac sat a North American P-51B Mustang, coded T9+CK in yellow paint. The aircraft had force-landed near Cambrai, France, 2 weeks earlier. Its pilot, Lieutenant Thomas Fraser of the 4th Fighter Group, had left the radio on as he climbed out, allowing his squadron mates to hear German voices examining the aircraft. The message was clear. They knew. And now, the Mustang was here. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching. From today, Bauer had examined dozens of Allied aircraft, Spitfires, P-47's, Mosquitoes. Each one told a story about enemy capabilities. But the Mustang represented something different. For months, Luftwaffe pilots had reported encounters with this American fighter at impossible distances from England, over Berlin, over Munich, places no single-engine fighter should be able to reach. The official explanation from Berlin was simple. These were isolated incidents, navigational errors by disoriented pilots, perhaps captured aircraft being flown by German pilots on special missions. The alternative was unthinkable. But Bauer was an engineer. He believed in mathematics, in physical laws, in fuel consumption rates and range calculations. And as he approached the P-51, clipboard in hand, he was about to discover a truth that would shatter every assumption about what was possible in this war. The Mustang sat with its drop tanks still attached. 2 cylindrical objects hung, beneath the wings, each marked with American stenciling. Bauer circled the aircraft slowly, noting every detail. The fuselage was sleek, aerodynamic, far more refined than the bulky P-47. The laminar flow wing design was elegant, minimizing drag. The Packard Merlin engine, visible through inspection panels, was a masterpiece of engineering. But it was the fuel system that would tell the real story. Bauer ordered his team to begin measurements. First, the wing tanks. Standard procedure. Measure internal volume, calculate capacity, cross-reference with captured intelligence documents. The junior engineers climbed onto the wing with measuring tapes and calibration equipment. After 30 minutes, they reported 92 US gallons per wing tank, 184 gallons total internal wing capacity. Bauer nodded. This was consistent with intelligence reports. The P-51B carried most of its fuel in wing tanks, an unusual design choice. Most fighters, German and Allied, placed fuel in the fuselage. But North American aviation had designed the Mustang's wing structure to accommodate large internal tanks between the forward and aft spars. One of the engineers pointed to the fuselage, just behind the cockpit. Herr Oberleutnant, there appears to be an additional tank here. Bauer climbed onto the wing and peered into the cockpit. Through the canopy, he could see the fuel selector valve. It had more positions than expected. He pulled out captured pilot manuals, documents obtained from interrogations. Yes, there it was, an 85-gallon fuselage tank, added midway through P-51B production. Total internal fuel, 269 gallons. Now the drop tanks. Bauer examined the cylindrical objects suspended beneath the wings. They were constructed of a pressed paper and plastic composite, lighter than metal, designed to be jettisoned after use. He measured their dimensions, calculated volume, 108 US gallons each. 216 gallons total external capacity. Bauer stood back. His mind was already running the calculations, but he needed to verify them on paper. He motioned to his team. Bring the fuel consumption data for the Merlin 61 series engine. They returned with technical documents, some captured, some compiled from Luftwaffe intelligence. The Packard V1650 engine consumed approximately 60 gallons per hour at economy cruise settings. At higher power settings, consumption increased, but for long-range missions, pilots would use economy cruise whenever possible. Bauer pulled out his slide rule. Total fuel capacity, 485 gallons, internal plus external. Fuel consumption, 60 gallons per hour. Basic calculation, 485 divided by 60. 8.08 hours of flight time. He stared at the numbers. That couldn't be right. He ran the calculation again. Same result. He checked the fuel capacity. Measurements. Verified. He confirmed the consumption rate. Accurate. 8 hours of flight time. Cruise speed of the P-51 at economy settings, approximately 280 miles per hour. 8 hours at 280 miles per hour, 2,240 miles of range. Bauer felt his stomach tighten. He looked at the aircraft again, then back at his calculations. The numbers were impossible. No single-engine fighter had that kind of range. It was more than twice the range of the Focke-Wulf FW-190. It was comparable to some bombers. One of the junior engineers noticed his expression. "Is something wrong, Herr Oberleutnant?" Bauer didn't answer immediately. He was thinking about operational implications. England to Berlin was approximately 550 miles. Round trip, 1,100 miles. But combat operations required reserves, allowances for maneuvering, for combat, for weather, for navigational errors. Even accounting for those factors, the P-51 could escort bombers to Berlin and back with fuel to spare. He thought about other targets. Munich, 600 miles from England, 1,100, round trip, still well within the Mustang's capability. Ploiești in Romania, 1,000 miles, 2,000 round trip. Theoretically possible, though requiring perfect conditions. The implications were staggering. Every major target in the Reich was now vulnerable to daylight bombing with fighter escort. Every factory, every rail yard, every fuel depot, the strategic bombing campaign, which had been suffering catastrophic losses just months earlier, now had the protection it needed. Bauer called for a meeting with the senior Luftwaffe intelligence officers. He needed to report this, immediately. But first, he needed to understand how this was even possible. The secret wasn't just the fuel capacity. Other fighters could carry drop tanks. The P-47, with external tanks, could reach respectable ranges. The P-38 Lightning had similar capabilities, but the Mustang outperformed them all because of a combination of factors that German engineering hadn't fully replicated. First, the laminar flow wing. The Mustang's wing design maintained smooth airflow over a larger percentage of the surface, reducing drag. Less drag meant better fuel efficiency. The Germans understood laminar flow theory, but manufacturing wings to the required tolerances was difficult, especially with wartime resource constraints. Second, the cooling system. The Mustang's radiator installation was revolutionary. It channeled cooling air through ducts beneath the fuselage, and the exiting air was actually accelerated, creating forward thrust. This Meredith effect partially offset the drag of the radiator itself. German aircraft couldn't match this efficiency. Third, the engine. The Packard-built Merlin wasn't just powerful, it was efficient. The two-stage supercharger maintained performance at altitude without excessive fuel consumption. The Germans had excellent engines, but they were optimized for different priorities. Power over efficiency, performance over range, and finally, the Americans had done something audacious. They'd added the fuselage tank despite the handling problems it created. With 85 gallons of fuel behind the cockpit, the P-51's center of gravity shifted dangerously aft. The aircraft became less stable, more difficult to fly. In combat with a full fuselage tank, it was genuinely dangerous. But American pilots had developed procedures to manage this. They burned the fuselage tank first, during climb-out and cruise to the combat area. By the time they encountered enemy fighters, the fuselage tank was empty, and the aircraft handled normally. Then they burned the drop tanks, jettisoning them before combat. By the time they engaged, they were flying on wing fuel only, with perfect handling characteristics. It was brilliant. Dangerous, but brilliant. Bauer documented all of this in his report. He included the measurements, the calculations, the tactical implications. He noted that the P-51's range wasn't theoretical, it was operational. Luftwaffe pilots were encountering these fighters daily over Berlin, over Munich, over targets deep in Germany. The report was classified Geheim, top secret, and sent to Berlin within 48 hours. The response came back 3 days later. Bauer was ordered to attend a briefing at Luftwaffe High Command, June 23, 1944, Berlin. The briefing room was austere, maps covering the walls, officers seated around a long table. Bauer presented his findings. He showed the fuel calculations. He explained the range capabilities. He detailed the tactical implications. The room was silent as he finished. Then a staff officer spoke. Oberst Werner Kriepe, Operations Planning. This assessment contradicts previous intelligence. We were informed the Mustangs extended. Range was achieved through mid-air refueling or through forward staging bases we haven't detected. Bauer chose his words carefully. Herr Oberst, the mathematics are straightforward. 485 gallons of fuel, 60 gallons per hour consumption. The aircraft can remain airborne for over 8 hours. The range calculations follow directly. Another officer, older, spoke up. And you're certain of these fuel capacity measurements? Absolutely certain. We measured the tanks directly. We also have confirmation from captured pilot manuals and interrogation reports. And the Americans are producing these aircraft in what quantities? Bauer consulted his notes. Intelligence suggests North American Aviation is producing approximately 400 aircraft per month at their California plant, with additional production at their Dallas facility. Total production may exceed 500 per month by summer. The room erupted. 500 per month. The number was incomprehensible. Germany was producing approximately 300 to 400 single-engine fighters per month total, across all types. The Americans were matching that with one aircraft model from one manufacturer, and every single one of those aircraft could reach Berlin. Kriepe's voice cut through the noise. If this assessment is accurate, and I emphasize if, it means the strategic situation is more serious than previously understood. Bauer waited. This was the moment where institutional denial either accepted reality or rejected it. However, Kriepe continued, we must consider the possibility that this is American disinformation. Captured aircraft deliberately modified to appear more capable than production models. False documentation planted for us to find. The Americans know we examine captured equipment. They would certainly attempt to deceive us. Bauer had anticipated this. Herr Oberst, the aircraft we examined was not prepared for capture. The pilot attempted to destroy the radio before being taken prisoner. There's no evidence of deliberate misinformation. Additionally, operational reports from our own pilots confirm these capabilities. Mustangs are regularly engaging our fighters over Berlin, then returning to England. Our pilots report many things in the chaos of combat. Perhaps they're encountering different aircraft at different times and assuming it's the same formation throughout. The identification is consistent. Distinctive airframe, unique engine sound, specific paint schemes. Our pilots know the Mustang when they see it. The discussion continued for another hour. Bauer presented every piece of evidence, answered every question, addressed every objection. But he could sense the resistance. The implications of his findings were too devastating to accept fully. Finally, a decision was made. The report would be distributed to fighter units as tactical intelligence. Pilots would be warned about the Mustang's capabilities. But strategic planning would not be fundamentally altered based on one captured aircraft. Bauer left Berlin frustrated but unsurprised. He'd seen this pattern before. When evidence contradicted ideology, evidence was questioned. But the evidence didn't care about ideology. The evidence was mathematical, objective, undeniable. And the evidence said Germany was facing an enemy who could strike anywhere, anytime, with fighter escort all the way to the target and back. Back at Rechlin, Bauer compiled additional data. He examined other captured P-51's as they became available. He interviewed captured American pilots. He studied combat reports. Every piece of information confirmed his initial assessment. The P-51 Mustang, equipped with drop tanks, had an operational range exceeding 1,600 miles. It could escort bombers to any target in Germany. It could maintain air superiority over the battlefield for hours. It could return to base with fuel reserves for emergencies. And the Americans were building them faster than Germany could shoot them down. One captured pilot, interrogated at Rechlin, was particularly informative. Captain James Mitchell, 8th Air Force, 357th Fighter Group. He'd been shot down over Munich in early June, forced to bail out after his Mustang took cannon fire from a Focke-Wulf 190. Mitchell was initially defiant, refusing to discuss operational details, but after several days, with the war clearly lost for Germany, he became more forthcoming. With full internal fuel and drop tanks, we briefed missions to targets over 1,400 miles round trip. That's with combat reserves, allowances for maneuvering, everything. If we were just trying to maximize distance, flying economy, cruise all the way? Hell, we could probably reach Warsaw and get back. And this is a standard production aircraft? No special modifications? Standard D model. Same aircraft every squadron has. Some guys would tape over panel gaps to reduce drag, little tricks like that. But the basic airframe? Straight from the factory. Bauer showed him the calculations. We measured a B model, 485 gallons total capacity, 8 hours flight time. Does this match your experience? Mitchell looked at the numbers. That's about right for the B model. The D model we were flying had slightly different fuel management, but similar range. We'd typically plan for 6 to 7 hours total mission time, flying out at altitude, combat in the middle, return trip dropping down to strafe targets of opportunity if we had fuel. And the handling with full fuselage tank? Terrible, Mitchell admitted. You didn't want to fight with that tank full. But procedure was to burn it first, so by the time we hit the combat area, it was empty. Then we'd drop the external tanks if fighters jumped us. After that, the aircraft handled beautifully. Made notes. Everything Mitchell said confirmed the technical analysis. Do you understand what this aircraft represents? Bauer asked. It means we can hit you anywhere, any time. It means your factories aren't safe, your fuel depots aren't safe, your rail yards aren't safe. It means the war is over, you just haven't admitted it yet. Bauer didn't respond. Mitchell was being intentionally provocative, trying to demoralize his captors. But he wasn't wrong. The mathematics were undeniable. The P-51 Mustang had solved a problem that had plagued air warfare since its beginning. How to project power over strategic distances with tactical aircraft. Bombers could fly far, but they were vulnerable. Fighters could protect bombers, but they couldn't fly far enough. The Mustang did both. It had fighter performance and bomber range, and that combination was devastating. The weeks following Bauer's report were a study in institutional paralysis. The information circulated through Luftwaffe channels. Fighter pilots received briefings about the Mustang's capabilities. Technical officers studied the data. Intelligence analysts updated their assessments. But nothing fundamentally changed. July 1944, the strategic bombing campaign intensified. American bomber formations, now escorted by Mustangs, struck targets across Germany with impunity. The 8th Air Force flew missions to Berlin, Leipzig, Munich, Stuttgart. Every major industrial center was within range. Luftwaffe fighter losses mounted. The tactics that had worked against unescorted bombers were suicidal against formations protected by long-range fighters. German pilots would climb to intercept altitude, prepare to attack the bombers, and find themselves engaged by Mustangs that had been escorting the formation for hundreds of miles. Major Gunther Roll, a highly experienced fighter pilot with over 200 victories, described the new reality in a combat report. We can no longer attack the bomber formations with confidence. The American fighters are always present, always in position. They have fuel to engage, disengage, and engage again. We make one pass at the bombers and must withdraw to conserve fuel. They can pursue us all the way to our airfields if they choose. This was the true strategic impact of the Mustang's range. It wasn't just that it could fly far. It was that it could loiter over the target area, maintaining air superiority for extended periods. A German fighter might have 10 or 15 minutes of combat fuel after flying to intercept altitude. A Mustang escort could fight for 30 or 40 minutes and still have reserves to return to England. The mathematics of attrition were brutal. Germany was losing experienced pilots faster than they could be replaced. Training programs were being shortened, quality was declining. New pilots arrived at frontline units with minimal flight time and were shot down on their first or second missions. And at the center of this catastrophe was an aircraft that, on paper, shouldn't have been possible. Bauer continued his work at Rechlin, examining additional captured Mustangs as they became available. Each one told the same story. In August 1944, a P-51D model arrived at the facility. This was the latest variant, with the distinctive bubble canopy that gave the pilot 360-degree visibility. Bauer and his team conducted the same analysis. Fuel capacity: 269 gallons internal, 220 gallons external, with the larger drop tanks that were becoming standard. Total: 489 gallons, slightly more than the B model, same devastating range. But the D model had other improvements: better visibility, improved armament, refined aerodynamics. It was, in every measurable way, a superior aircraft, and the Americans were building them at an accelerating rate. Bauer included this information in his monthly intelligence summary. He noted that North American aviation's production had indeed exceeded 500 aircraft per month, just as captured documents had suggested. By late 1944, total P-51 production would approach 8,000 aircraft, with plans for even higher rates in 1945. Germany's entire fighter force numbered approximately 2,000 aircraft at any given time. The Americans were building more Mustangs in 2 months than Germany had operational fighters. The disparity wasn't just in numbers, it was in capability. A single Mustang could accomplish missions that required multiple German sorties. Its range meant it could operate over any part of Germany. Its endurance meant it could protect bomber formations for the entire mission. Its performance meant it could engage and defeat Germany's best fighters. One aircraft, mass-produced, operationally decisive. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The question haunting Bauer was simple. Could Germany have built something equivalent? He spent hours analyzing the problem. The Mustang's range came from multiple factors: efficient aerodynamics, effective cooling system, fuel-efficient engine, and crucially, the willingness to accept handling compromises for extended range. Could Germany replicate this? The aerodynamics were achievable. German engineers understood laminar flow theory. The Focke-Wulf TAR 152 was being developed with similar concepts. The cooling system was more difficult. The Meredith effect required precise engineering and high-quality manufacturing. With Germany's industrial base under constant bombardment, maintaining such tolerances was challenging. The engine was the real problem. Germany's aircraft engines were excellent, but they were designed for different priorities. The Daimler-Benz DB605 and BMW 80 were powerful, reliable, well-engineered, but they consumed more fuel per hour than the Merlin for equivalent power output, and Germany didn't have the fuel to spare. This was the deeper crisis that Bauer's analysis revealed. The Mustang's range wasn't just about fuel tanks and efficient engines, it was about industrial capacity. The Americans had effectively unlimited access to petroleum. They could design aircraft around range requirements because fuel wasn't a limiting factor. Germany was already rationing aviation fuel. Pilot training was being curtailed not because of aircraft shortages, but because there wasn't enough fuel for training flights. Operational units sometimes had aircraft sitting idle because no fuel was available. Building a long-range fighter meant accepting even higher fuel consumption per mission. It was a strategic impossibility. Bauer documented this in a supplementary report titled Strategic Implications of Enemy Fighter Range Capabilities. The report was detailed, thoroughly researched, carefully argued. It concluded that Germany lacked the resources to develop an equivalent capability, and that continued attrition against numerically and technically superior enemy aircraft would result in the collapse of air defences within 6 to 12 months. The report was classified and filed. Bauer never received an official response. But he heard through informal channels that Reichsmarschall Hermann Göring had been briefed on the Mustang's capabilities. Göring's reported response was dismissive. American propaganda. They build refrigerators and automobiles, not fighter aircraft. When informed that the range calculations were based on captured aircraft and confirmed by Luftwaffe pilots, Göring allegedly replied, "Then our pilots are being deceived by their own fears." This was the institutional culture that Bauer was working within. Evidence was subordinate to ideology. When reality contradicted the approved narrative, reality was rejected. October 1944. The skies over Germany were now dominated by American fighters. Missions that would have been impossible a year earlier were now routine. 8th Air Force bombers struck Berlin in daylight with formations of 600, 700, 800 aircraft, escorted by hundreds of fighters. Luftwaffe interception attempts were sporadic and increasingly ineffective. The combination of fuel shortages, pilot losses, and overwhelming American numbers had broken the back of German air defense. At Rechlin, Bauer compiled his final major report on the Mustang. He had now examined 6 different examples, interviewed a dozen captured pilots, analyzed hundreds of combat reports. The conclusion was inescapable. The P-51 Mustang represented a fundamental shift in air warfare doctrine. It had solved the bomber escort problem that had plagued strategic air campaigns since the First World War, and in doing so, it had given the Allies the ability to conduct sustained, large-scale daylight bombing of industrial targets deep in enemy territory. The consequences were already visible. German aircraft production, despite Speer's efforts to disperse manufacturing, was declining. Fuel production was collapsing under sustained bombing of refineries. Transportation networks were being systematically destroyed, and none of it could be stopped because the Luftwaffe no longer controlled its own airspace. Bauer's report included a section on lessons learned. If Germany survived this war, if there was ever another conflict requiring long-range air operations, these were the principles that mattered. 1. Range is a strategic capability. An aircraft that can reach any target fundamentally changes the operational calculus. 2. Industrial capacity matters more than individual aircraft quality. A good aircraft in large numbers defeats an excellent aircraft in small numbers. 3. Fuel efficiency is a design priority equal to speed and firepower. An aircraft that can't reach its target is useless, regardless of its other capabilities. 4. Institutional honesty is essential. When intelligence contradicts approved narratives, the narratives must change, not the intelligence. The last point was perhaps the most important. Bauer had provided accurate assessments of the Mustang's capabilities in June 1944. If those assessments had been accepted and acted upon immediately, Germany might have altered strategy, increased dispersal of industry, prioritized jet fighter development, modified defensive tactics. Instead, the information was filed away, and the strategic situation continued to deteriorate for another 10 months until Germany's final collapse. December 1944. By now, the Mustang was ubiquitous over Germany. Luftwaffe pilots called it Indianer, from the Native American head emblem many 8th Air Force groups painted on their aircraft. The warning cry, "Achtung Indianer," on the radio meant Mustangs in the area, and for German pilots, that increasingly meant breaking off attacks and running for home. The famous quote attributed to Hermann Göring captured the psychological impact. "When I saw Mustangs over Berlin, I knew the war was lost." Whether Göring actually said those exact words is debatable, but the sentiment was accurate. The appearance of American single-engine fighters over the German capital, 1,100 miles from their bases in England, flying with fuel reserves for combat and return flight, was a demonstration of American industrial and technological capability that could not be answered. Bauer was not present for the final collapse. In January 1945, with Soviet forces approaching from the east, Rechlin was evacuated. Test aircraft were flown to facilities in southern Germany or destroyed to prevent capture. Personnel were reassigned to combat units or sent to underground factories. Bauer spent the last months of the war at a dispersed facility near Munich, continuing to analyze captured equipment even as the Reich disintegrated around him. In late April 1945, with American forces approaching, he burned his remaining classified documents and waited for the inevitable. May 8, 1945, Germany surrendered. Bauer was captured by American forces and immediately identified as a technical intelligence officer. His expertise in captured aircraft evaluation made him valuable to US. Over the following weeks, Bauer was extensively interrogated by American technical officers. They were particularly interested in his June 1944 report on the P-51 Mustang. Had German leadership understood the strategic implications? Why had the information not resulted in changed tactics or strategy? Bauer's answers were honest. Yes, leadership had been informed. No, they had not fully accepted the implications. The institutional culture of the Third Reich made it dangerous to deliver bad news. Officers who reported uncomfortable truths were accused of defeatism. Better to remain silent than to risk one's career or life. But surely, one American officer asked, when your own calculations showed the Mustang could reach Berlin, when your own pilots confirmed it operationally, surely that evidence was undeniable. Bauer smiled bitterly. In Nazi Germany, evidence was not undeniable. Ideology was undeniable. When they conflicted, evidence was adjusted or ignored. The Americans showed him production figures for the P-51. By war's end, over 15,000 had been built, more than any German single-engine fighter type. The Mustang alone outnumbered Germany's entire operational fighter force at its peak. Could Germany have built something equivalent? The American officer asked. Bauer thought carefully before answering. Technically? Perhaps. We had capable engineers, good design teams. We could have developed the aerodynamics, the systems. But strategically, no. We lacked the resources, the fuel, the industrial capacity, the time. Even if we had started in 1943 when we first encountered the Merlin Mustang, we could not have fielded an equivalent capability before war's end. So the Mustang was a war-winning weapon? Not by itself, Bauer replied, but it was a critical enabling capability. It allowed your bombers to reach any target in Germany with acceptable losses. That destroyed our industrial base, our fuel production, our transportation network. Without the Mustang, the strategic bombing campaign might have failed. With it, Germany's defeat became inevitable. The interrogation continued for days. The Americans wanted every detail: technical assessments, tactical reports, strategic implications. They were already thinking about the next war, the next generation of aircraft, the lessons to be learned. One question kept recurring. Why had the Mustang been so successful when other long-range P-50's fighter attempts had failed? Bauer's answer was consistent: integration of multiple technologies. No single feature made the Mustang successful. It was the combination of efficient aerodynamics, effective cooling, fuel-efficient engine, large internal fuel capacity, and operational doctrine that exploited these capabilities. And the drop tanks? The American asked. Essential, Bauer confirmed. Without external fuel, the Mustang's range would be good, but not revolutionary. The drop tanks doubled the operational radius, and your use of lightweight, disposable paper composite tanks was brilliant. Lower weight penalty, lower cost, no strategic materials required. We never developed anything equivalent. The Americans were surprised by this. To them, the paper drop tanks had been an expedient solution to a manufacturing bottleneck. They hadn't realized the Germans considered them a technological achievement. You could have built paper tanks, one officer said. Could have. Bauer agreed, but didn't. That's the difference between your Air Force and ours. You solved problems pragmatically. We often over-engineered solutions or didn't solve them at all. After weeks of interrogation, Bauer was released from custody and allowed to return to civilian life. His technical expertise could have been useful to the Americans, but he declined offers to work on post-war aviation projects. He'd had enough of military aircraft. He returned to his hometown, found work as an engineer in civilian manufacturing, and tried to forget the war. But he never forgot the moment in June 1944 when he stood next to a captured Mustang, slide rule in hand, and realized that the numbers told a story of Germany's inevitable defeat. 485 gallons of fuel, 60 gallons per hour consumption, 8 hours of flight time, 2,000 miles of range. The mathematics were simple, the implications were devastating, and the institutional response was denial. Bauer lived until 1973, dying at age 62. In his later years, he occasionally gave lectures to engineering students about aircraft design. His favorite topic was the P-51 Mustang. He would show the specifications, walk through the range calculations, explain the technical innovations, and then he would tell the students about his June 1944 report, about measuring the fuel tanks, about running the numbers on his slide rule. The most important lesson, he would say, is not about engineering, it's about intellectual honesty. When the evidence tells you something you don't want to hear, you have two choices: accept the evidence and adapt, or reject the evidence and fail. Germany chose failure. Learn from our mistake. The P-51 Mustang destroyed 4,950 enemy aircraft during World War II. It escorted thousands of bombing missions. It helped achieve air superiority over Europe. It enabled the strategic bombing campaign that crippled German industry. But perhaps its most important contribution was the lesson it taught about the relationship between industrial capacity, technical capability, and strategic outcome. America had the resources to design an aircraft around range requirements. They had the fuel to operate it. They had the industrial capacity to build it in decisive numbers. And they had the operational doctrine to exploit its capabilities. Germany had none of these advantages. And when German engineers examined a captured Mustang and discovered its true range, they were confronting not just an aircraft's specifications, but the mathematical proof of their nation's strategic inferiority. One captured P-51, one set of measurements, one calculation on a slide rule. And suddenly, undeniably, the truth was visible. Germany could not win a war of industrial attrition against an enemy who could build fighters with bomber-like range and produce them by the thousands. The Mustang's drop tanks carried more than just fuel. They carried the weight of American industrial might. And when German engineers calculated the range those tanks provided, they were calculating the distance to Germany's defeat, 1,600 miles. The distance from England to Berlin and back, the distance between hope and inevitability, the distance Germany could not close. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The American interrogations revealed another dimension to the Mustang story that Bauer hadn't fully appreciated during the war: the development timeline. Major Robert Henderson, a technical intelligence officer who had worked on Mustang development at Wright Field, showed Bauer a classified chronology of the aircraft's evolution. The dates were striking. April 1940. British Purchasing Commission approaches North American Aviation, requesting they build Curtiss P-40 Warhawks under license. North Americans' response: "We can design a better fighter in 120 days. October 1940. The NA-73 prototype flies for the first time. 117 days from contract signing to first flight. Bauer stared at the timeline. 4 months? From clean sheet to flying aircraft in 4 months? Henderson nodded. Dutch Kindleberger and Edgar Schmood's team worked around the clock. They used NACA wind tunnel data, incorporated every advanced aerodynamic concept available, designed for ease of production. The prototype flew before some of our internal design reviews were complete. But this initial version had the Allison engine, Bauer noted. Limited high-altitude performance. Correct. The early Mustangs were good low-altitude fighters and excellent reconnaissance aircraft, but they couldn't escort bombers at 25,000 feet. The real breakthrough came later. Henderson showed him another document, October 1942. Rolls-Royce test pilot Ronald Harker flies an Allison Mustang and immediately recognizes that installing a Merlin engine would transform the aircraft. The British begin conversion work at Rolls-Royce's Hucknall facility. November 1942. The first Merlin Mustang flies. Performance is spectacular. December 1942. North American receives contracts for the P-51B with Packard-built Merlin engines. June 1943. First P-51B models roll off production lines. December 1943. First operational escort missions over Germany. Less than 3 years, Henderson said, from initial concept to operational deployment of a war-winning weapon. And the aircraft kept improving. The fuselage tank was added mid-production. The D model with bubble canopy came less than a year later. Each iteration refined the design. Bauer considered this timeline against Germany's fighter development programs. The Messerschmitt Me-262 jet fighter had been conceived in 1938, but didn't enter operational service until 1944. 6 years. The Heinkel He-2 19 night fighter took 5 years from initial design to operational deployment. Your development cycle was faster than ours, Bauer observed. In some cases, yes, but it wasn't just speed, it was flexibility. When we identified a problem, we fixed it immediately. The early Mustangs had issues with the Allison engine at altitude. We changed the engine. The pilots wanted better visibility. We redesigned the canopy. They needed more range. We added internal fuel capacity. Every problem had a solution, and solutions were implemented quickly. This was another lesson. The Mustang wasn't perfect when it first flew. It was good enough to get into production, and then it was continuously improved based on operational feedback. German development often aimed for perfection before production, resulting in delays and missed opportunities. Henderson pulled out another document, a cost analysis. Do you know what a P-51D cost to manufacture in 1944? Bauer shook his head. $51,000, about 51,000 Reichsmarks at the exchange rate. Bauer was stunned. A Focke-Wulf FW-190 cost approximately 100,000 Reichsmarks to produce, and it had half the Mustang's range. The Americans were building a superior aircraft for half the cost. How? Bauer asked. How is that possible? Mass production techniques borrowed from the automotive industry. North American's plant in Inglewood was designed like a car factory. Assembly line production, standardized components, minimal hand-fitting. At peak production, they were completing one P-51 every hour. One aircraft, every hour. For months on end. One aircraft per hour. Bauer tried to comprehend the scale. That was more than Germany's entire daily fighter production across all manufacturers, Henderson continued. And the Packard Merlin engines? Ford was building them using automotive production methods. The same company that built Model A cars was producing one of the most sophisticated aircraft engines in the world, thousands per month, to consistent quality standards. This was the industrial reality that Bauer's technical reports had only hinted at. Germany wasn't just facing a better aircraft. Germany was facing an industrial system that could design, develop, produce, and continuously improve advanced weapons at a scale that was simply incomprehensible. The drop tanks, Henderson said, producing another file. You mentioned in your report that you found them remarkable. Do you know when we started using the paper composite tanks? I assumed from the beginning. No. Initially we used metal tanks. Aluminum. But aluminum was needed for airframes, so we developed the paper composite design. Lighter, cheaper, used no strategic materials. They could be manufactured by companies that had never built aircraft components before. Furniture manufacturers, paper mills, anybody with the right equipment could produce them. He showed Bauer photographs of drop tank manufacturing facilities. One was a converted paper mill in Michigan. Another was a furniture factory in North Carolina. Tanks stacked by the thousands, ready for shipment. Total production of 108-gallon drop tanks exceeded 1 million units during the war. 1 million disposable fuel tanks. That's more tanks than Germany produced aircraft. The numbers were overwhelming. Bauer had understood that America had industrial advantages, but seeing the detailed production figures, the cost analyses, the manufacturing timelines, made the disparity tangible in a way that abstract knowledge never could. Henderson seemed to sense Bauer's thoughts. You want to know why I'm showing you all this? I assumed for intelligence purposes. Understanding what we knew, and when we knew it. That's part of it. But there's another reason. We're going to have to work with German engineers and scientists going forward. The war with Japan isn't over yet, and then there's the Soviet situation. We need people who understand what happened here, who can learn from it. He paused, choosing his words carefully. Your reports were good. Accurate, detailed, honest. You told your leadership the truth, even when that truth was uncomfortable. That's rare. That's valuable. The Americans wanted technical expertise for the coming conflicts, but he was tired. Tired of war, tired of weapons, tired of calculating the mathematics of destruction. I appreciate the offer, Bauer said, but I think I'm done with military aviation. Henderson nodded, unsurprised. I understand, but before you go, I want you to understand something. The Mustang wasn't just a good airplane. It was a symbol. It represented what America could do when we committed our industrial capacity to winning a war. Every time a Luftwaffe pilot saw Mustangs over Berlin, he wasn't just seeing enemy fighters. He was seeing proof that Germany couldn't win. We understood that, Bauer said quietly. Some of us, anyway. We understood it in June 1944 when we measured those fuel tanks. We understood it every time we ran the range calculations. 485 gallons, 8 hours flight time, 1,600 miles range. The mathematics were undeniable. But your leadership didn't act on that understanding. No, they didn't, and that's perhaps the most important lesson of all. Technical excellence means nothing without strategic wisdom. We had excellent engineers, good designs, capable pilots, but we lacked the strategic vision to accept reality and adapt accordingly. Henderson closed his files. That you understand not just what happened, but why it mattered. The Mustang changed air warfare. Any future conflict will require long-range fighters. The days of short-range interceptors are over. Range is now a fundamental requirement, not an optional feature. He was right, of course. The lesson of the Mustang would shape fighter design for decades. The American F-86 Sabre, the Soviet MiG-15, every jet fighter that followed, would incorporate the principle that range and endurance were essential capabilities, and it all traced back to one American fighter with drop tanks carrying 485 gallons of fuel, capable of escorting bombers to Berlin and back. One aircraft, one calculation, one undeniable truth. Germany could not win.